An approach for image enhancement based on improved joint bilateral Retinex. Abstract: image enhancement is a crucial technique to accentuate images with poor illumination in order to achieve better image interpretation. Retinex theory is a classic image enhancement technique for improving poor illumination in the digital image. In this work, an experiment is carried for the improvement of poor illumination in an image to aid better enhancement based on Retinex theory with improved joint bilateral filter, which enhances the poor illumination of digital images without compromising the edges. From the results, it is observed that the combination of Retinex theory with joint bilateral filters aids better image enhancement. Digital image, keywords, Retinex theory, bilateral, image enhancement, illumination. Introduction. Image enhancement plays a vital role in many image processing applications. The idea behind image enhancement is to improve the given image to be a better image by applying some technique for better human interpretation or to send as input for further analysis. 1. Some of the image enhancements techniques comprise of wavelet transform, gamma correction, spatial filtering techniques and histogram equalization. 2. Retinex theory is the classic image enhancement technique which is proposed by Land 3 that aids better image enhancement by improving the poor illumination in the image. To handle halo effect of Retinex theory and to achieve color restoration, joint bilateral filter can be used. The joint bilateral filter, which is proposed by Eisman and Durand, for an altered edition of bilateral filter which splits the impression of edges and protects it to get smoothened. 2. Literature. Li Yang et al. 5 proposed a trilateral filter-based Retinex for the image contrast enhancement and achieved a good solution. Ling Tang et al. 6 proposed an improved Retinex theory for the image enhancement, and from the results it is concluded that the proposed method achieves improved image enhancement. Nirmal Jith et al. 7 proposed a denoising algorithm based on joint bilateral filter and achieved better denoising for high-noise image. Wanda et al. 8 proposed enhancement technique for the image enhancement for local mode filtering. Shuang Fu et al. 9 proposed a method to eliminate uneven illumination and achieved better results when compared with the existing methods. Shi Tang et al. 2 proposed a color image enhancement based on Retinex theory with guided filter and achieved improved result in handling halo effect and image loss when comparing the existing results. 3. Basic Retinex methods. The role of Retinex theory is to decouple an image into two components, they are illumination and reflectance. The Retinex theory reduces the impact of illumination of the reflectance. The main ideology behind the Retinex is reconstruction of image which mimics human visual system, and an image can be defined as follows. Wherein xy is the given image, ln xy, illumination of given image, and rn xy is the reflectance of the object. In order to enhance the image, the illumination compound has to be suppressed and the reflectance compound has to be maintained, that can be defined as ln xy can be estimated by wrapping in xy with the Gaussian function gs xy, where s is the Gaussian function standard deviation, asterisk denotes the convolution operation. Gs xy can be defined as, while substituting equation 4 and equation 5 and equation 3 resulting in single-scale Retinex, SSR. The reflection compound Rn, xy, is stated as, where min, log Rn, xy, is minimum of log Rn, xy, and where max, log Rn, xy, is maximum of log Rn, xy. The multi-scale Retinex is defined as, where n is the number of SSR2. 4. Proposed improved joint bilateral Retinex method. Different shades of Retinex image enhancement techniques have evolved to handle unevenness in the images. Halos and smoothing of edges is still a challenging issue in Retinex theory. Usage of filtering technique can protect the images from halos and excessive smoothing. In this section, Retinex theory with joint bilateral filter has been experimented to achieve improved image enhancement based on Retinex technique. Figure 1 depicts the process flow of the proposed method. First, the given image is transformed to RGB to Xi, hue, saturation, intensity, space. Gamma corrections are used to improve the channel I. It is defined with power expression, where I is raised to the power of gamma. X is a non-negative real input value and multiplied with a constant C gamma correction is used to enhance the channel I as in equation 10. Where G, XY, gamma corrected image. G, XY, is the actual image. Estimation of illumination image is carried with joint bilateral filter to suppress the color degradation 10, 11, 12. Where XP is the image value at PWP is the normalization factor ensures pixels weight sum is 1.0. Generally bilateral filter ensures two weights viz the geometric weight is in the spatial domain. GSR photometric weight in the range domain. SS and SR determines the filtering level. FXP is the target image, Y is the given image. PQ is the Euclidean distance between the pixel location P and Q. In joint bilateral filter a guidance image is used instead of filtered image. Compression for the illuminant image is defined as follows. Decomposition and enhancement of the reflected image is defined as. The brightness of output and input is represented in G, XY, G, XY. G, XY, represents neighborhood mean of 3x3 region. K is the gain coefficient between 0 and 1. Then adjustment of S channel is defined as. Where S, XY, corrected saturation and S, XY, represents the uncorrected saturation. The coefficient proportional between 0 and 1 is represented as T. V. Results and discussion. The proposed method is implemented in MATLAB and validated with the existing techniques like single-scale Retinex and multi-scale Retinex. PSNR and MSE are used as validation parameter. Figure 2 shows the results of proposed method and other existing technique. A. Actual picture. B. Single-scale Retinex. C. Multi-scale Retinex. D. Proposed method. Figure 2 output of proposed method with the existing methods. A. Peak signal to noise ratio, PSNR. PSNR technique is a quality measure that is used in computing the compression ratio between actual and the proposed image. Equals 10, 2552. 17. B. Mean square error, MSE. Mean square error is the error metrics used to find the compression ratio. The lower the value of MSE, the lower the error. Equals 1 times. Comma. 2, equals 1, equals 1. 18. Methods. PSNR value of the image. MSE value of the image. Single-scale Retinex. 13.295. 0.445. Multi-scale Retinex. 13.987. 0.223. Proposed method. 14.334. 0.222. Table 1 results of the proposed method and the existing method. 6. Conclusion. The proposed image enhancement method effectively improves the poor contrast of the given image. In this paper a joint bilateral Retinex is experimented and evaluated based on the metrics PSNR and MSE. From the results it is concluded that the proposed method achieves better image enhancement when compared with the existing method.